Hey, this is Stereo Police back with a fairly brief follow-up to yesterday's, well, I say yesterday's, but yesterday I posted and made a video regarding damping factor, output impedance, and speaker cable resistance. And I felt, after I posted it and watched it, I felt it was a little incomplete because it seemed, the purpose of the video was more to be informative and educational. And it wasn't to be alarmist about anything. And it occurred to me at the end, I seem to have some sort of a paranoia about speaker cable resistance, and it's really not. That's not the case. I just found all that theory and the the idea of a speaker cable resistance factoring into both system damping factor as well as a frequency response. I found that to be interesting. It was just more or less to underscore the importance of having enough gauge speaker wire and short enough runs. But the reality is most everybody's speaker wire is probably more than acceptable. If you're using 16 gauge, 12 gauge, and your speakers are only 6-8 feet away from your amp, there really shouldn't be any problem whatsoever. And I want to show you that. I want to prove that to you. However, I like taking things sometimes to the extreme just because it's fun. And that's what I'm going to get to at the very end of this presentation. But I just want to show you that, for the average person's setup, the speaker wire they probably have is perfectly fine. But on the other hand, those situations, I recall growing up, we were kids and we were toying around with stereos, and I didn't know physics or science, and you had, oftentimes we had this, trying to find it here, we would use whatever wire, we didn't think about wire, we'd use, this stuff here. I don't know what gauge, it's somewhere in the 20s, I don't know what it is, but just any old wire, and just hook it up to your speakers and run your speakers across the basement 50 feet 80 feet away from the amp with this stuff right here. Well, yeah, that is a problem. But and we didn't know back then, probably, that our system was, our stereos were terrible and horrible enough to where it doesn't matter, they sounded like crap, although I had a few that sounded pretty good. But when you're using the big stuff, when you're using decent speaker cable and for short runs, it's really not a factor. And I want to show you that. So what I've printed out here, and all copper, wire, and other materials, they all have an inherent resistivity, and that gets into the physics of it. And I'm not going to run numbers with resistivity, but I'm going to show you. I pulled a chart, I think it's for electricians, and I pulled it from this source right here, and there's plenty of sources for this stuff, but I'll show you the source. And they have a huge table of different wire gauge, and this is for stranded wire, by the way. Solid wire is different, slightly different, but speaker cable we use stranded wire. So for stranded wire, I pulled off this colossal table a couple of samples, okay? And what we have here is the gauge of the wire versus the ohms, the resistance, and I put about because I rounded up, these were in decimals, resistance per 1,000 feet. And as you can see here, 22 gauge wire, the thin stuff, 1,000 feet, 17 ohms, right? 20 gauge, 10 ohms, 16 gauge, 4, and 12 gauge, 2 ohms. So you can see just from this this alone what how important it is to get a wider diameter wire, a smaller gauge. Again, I go with 12. Now, I want to run a couple scenarios on the effects. And I'm going to start with an extreme bad scenario and work towards the best scenario. And one of those scenarios in between is probably what you have and what I currently have, which is acceptable. And I'll run through that. But I want to run through some scenarios on the effects of wire runs versus the effects on damping factor, and also those, I didn't get into it, but all of these things, when you have a high resistance wire, it will affect frequency response too. But I'm going to look at damping factor. So let's run a scenario. And by the way, I just finished up with these slides and had my little calculator. If I miscalculated something, hit the wrong button, I didn't go back and proof this, then someone will correct me on that, I'm sure, and I have no problem with that. So let's start out with a scenario where these are the 10-year-olds in the basement hooking up their stuff. Where you needed 50 feet. You have a 50-foot run from your amp to your speaker, and they're using 22 gauge wire. A bad situation, of course. So, given the fact that we have 17 ohms per 1,000 feet with 22 gauge wire, so 17 divided by 1,000 equals X. X is the resistance that we're going to determine for 50 feet. Okay, divided by 50 feet. So we just bring the 50 up, multiply by 17, and divide by 1,000. And that one length, I'm not talking about two ways, I'm talking about one way. From the positive, for example, from the positive side speaker terminal of the amp to the positive of the speaker, 0.85 ohms. That's fairly high. It's high enough to, affect the damping factor. So 0.85 ohms, what effect does that have on damping factor? Well, using the same scenario that we've already calculated in the previous video, using my R9 for example. R9 Yamaha is spec'd out at damping factor of 60 at 8 ohms, which means it has a 0.13 ohm output impedance. And using the same equations, I won't get into those again, for calculating system damping factor, our damping factor with our 50 foot of 22 gauge wire is 8 divided by 0.13 plus 2 times the run. Okay, you got a positive lead and a negative lead. 2 times 0.85 ohms, and we get 4.37. Now, as you can see, I was just verifying my math there. We had this amp with a damping factor of 60, and I've destroyed it. I've taken that damping factor down to 4.37. Little to no control over the bass. Absolutely horrible. Not to mention that you've got essentially 1.6 ohm resistor in line with your speakers, and if your speaker is roughly 8 ohms, you're dissipating power in the line. You don't want that either. Not to mention the effect on frequency response will be tremendous. Okay, again, that was our terrible situation. Let's make it better. Let's make it more realistic, a more reasonable scenario. Let's say I have 8 feet of wire. Let's say my speakers are roughly 8 feet away from the amp, or I've got to run them in such a way that I need 8 feet, and I'm using 16 gauge wire. Okay, not unreasonable. So at 16 gauge wire, the spec is about 4 ohms per 1,000 feet. So 4 divided by 1,000, or the ratio of 4 to 1,000 equals the ratio of X, the resistance we're looking for at 8 feet. Run the numbers, 0.032 ohms per one-way run. Pretty low, right? Well, let's see what effect that has on our damping factor. Using the same amplifier, damping factor of 60, spec'd out at 8 ohms. It's part of the spec. So we have our 0.13 ohms output impedance. So 8 divided by 0.13 plus 2 times for both runs, positive and negative, 0.032. Damping factor is now 41. So we have reduced the damping factor by roughly a third. 41 is still good, but for me, well, now that I think about it, I'd like to do a little better than that. I'd like to have less of an effect on that damping factor. So what do? Well, let's go out and buy some better cables, or some smaller, lower gauge cables. Okay, this was so let's go down to 12 gauge. Okay, we were at 16 before. Let's get 12 gauge. 12 gauge isn't that much more expensive. So let's run the numbers at 12 gauge. And knowing that at 12 gauge we have about, half this. It's a half, okay? We have about 2 ohms per 1,000 feet. So a ratio of 2 to 1,000 equals the ratio of X that we're looking for to 8, because we're sticking with our 8 feet from our speakers. So that's 0.016 ohms, half what it was before. And let's see what effect that has on our damping factor. Running the numbers, our damping factor is now reduced from 60 to 49, rather from 60 to 40. Let's see, what was it before with the... I have thrown my papers all over the place. Okay. With our 16 gauge, we went from 60 to 41. Now with our 12 gauge, 60 to 49. So there you have it. Not bad, right? Only reducing the damping factor by about 10. So that's perfectly acceptable. Using 12 gauge wire at 8 feet, no problemo. That's totally fine, right? But let's get ridiculous. I like that. Let's take it to the extreme. And I'm actually going to do this. That's what a knucklehead I am. I just, once I got to thinking about this yesterday, I'm thinking, well, what the hell? That's why I went out and I found this really beat up, half-used roll of 12 gauge speaker wire. And I've got enough to make this happen. I got a good deal on that. Okay. Let's get ridiculous. So let's start paralleling wires. So I had the last scenario we did is I had my 12 gauge and I ran it 8 feet, right? And the resistance, what was the resistance of that? 0.016. So that's essentially drawing it as a resistor, which a wire is, 0.016. By the way, you can't measure that on a DVM. You can barely measure below an ohm with a typical DVM. It's not accurate. It's not precise enough. Can't do it. There are ways to measure low resistances. There's a really cool way to do it. I might do a video about one day that you can use your DVM, but you can't use it on the ohm scale, the resistance setting. You have to you can do it using current, or you can do it using voltage, and most DVMs will measure fairly precise down to the millivolt, and we can take advantage of that aspect and measure the resistance using a simple 9-volt battery and an inline resistor. Think about it. You might be able to come up with it. But that's something for another day. Or you can use a bridge, but most people don't have bridges for low resistance measurements. Now, that's old school too. Okay, so let's start paralleling these wires. Let's parallel 5 of them and connect them all together at the ends. 1, 2, 3, 4, and 5. And of course, whenever you start paralleling resistors, the total resistance is going to get lower and lower and lower and lower. So what do we get if we parallel, knowing we have 0.016 ohms and we parallel 5 of them? Well, the equation for paralleling resistors R equals 1 over R1 plus 1 over R2 plus 1 over R3, right? That's the equation right there. And every one of these R's is going to be 0.016. So what we have here is 1 over 5 times 1 over 0.016. And running the numbers, we get 0.0032. So now we have a speaker wire that has a 0.0032 ohm resistance. Way low. Now let's see what effect that has on damping factor. Running the same equations we did before. 8 divided by 0.13 8's our load, our spec'd out load. Damping factor is spec'd out at being measured at the factory at 8 ohms. Divided by 0.13, the internal resistance that we calculated of the amp, 2 times 0.0032, it is 59. Right? When I run that number, that looks pretty darn good. 59. So what we've done there is we've taken our spec'd out amp that had a damping factor of 60, and with this amazing paralleled cable, we've only reduced it by 1 point. That is, well, quite frankly, that's what I want. And I don't think I've ever done that. I've never done this before. I've always just relied on my 12 gauge cables, and I've been happy. But I would love to know if there's any difference in sound between, for example, where's our 12 gauge scenario? You know, where we've reduced our damping factor by, 10 versus 1. Now, granted, here's one more thing. The amp I'm currently using has a damping factor, and many people have amps with damping factors that start out much higher, like 250. And so, the 12 gauge, and I haven't run these numbers, but the 12 gauge, I'm going to make it up, but the 12 gauge 8-foot run might only reduce that to like, 210 or something. Well, we already have we started out at ridiculously high. We're going to end up at ridiculous high, no problem. But in my A1000, the amp that I really like, and this is one of the reasons I'm doing it. By the way, the 250 is my AS1100. So I'm starting out ridiculously high. I'm not worried about using a single 12 gauge 8-foot run, right? But my and this 60 is for the R9 Yamaha. But the amp I love listening to is my A1000, and it has a damping factor of 40 to start with. And it's a great amp. I love it. It just starts out low. It's got a damping factor of 40. It's inherent. So I don't want to reduce that 40 by too much. I don't mind reducing the 250, but I don't want to reduce that 40 by too much. And that's where I'm really curious if these massively paralleled 12 gauge cables are going to make any difference. And perhaps the difference I hear might be purely psychological. I am susceptible to that for some things, not for total bullshit, but for things that have a basis in science and fact. I like to have that psychological peace of mind, okay? For a lot of these audio mysticism bullshit things, no way. I'm not gonna fall for that stuff. But this sort of thing has a firm basis in reality, and so I'm looking forward to actually doing it. I am actually going to piece together. I don't know how I'm going to connect these cables and come up with the connectors on the ends yet, but I'm going to do it. I'm looking forward to it too. So, anyway, I hope you found this follow-up helpful. The takeaway is, I hate that expression, the takeaway. I hear that when people give lectures. Strike that. Not the takeaway. What's another? The conclusion. And the point I'm trying to make is the average person's speaker cables are just fine. I didn't intend to make that previous video to say that everyone's got a big major problem, you need to go out and fix it. Okay, in summary, the major problems are where you have long runs of ridiculously fine cable. Most of us don't have that, so what we have is acceptable. I'm just doing this for the educational value as well as building this 5 cluster wide cable just for the fun of it and just for the experience of it. And who knows, maybe I'll hear something, whether it's psychological or whether it's in reality, that I'll appreciate and like and want to stick with these cables. So anyway, it's all part of the hobby. It's all enjoyable. It's all fun to me. It's all fascinating. I've never lost the fascination for this stuff. So anyway, thanks for watching. I think this particular video is geek level 10, but what the hell? I usually get 2 or 3 people that really appreciate it, so that's all I live for, is those 2 or 3 people that say hi. thanks for the video. Anyway, thanks for watching again, and this will be my final video on this topic. Enjoy. Ciao.